We've reached the end of yet another module, and we've extended our knowledge on classes quite a bit. We looked at namespaces, and we've learned that their main goal is grouping classes to avoid name conflicts. We've also seen static members. Making something static means that it's class level. Classes allow us to model real-life structures like an employee or a car, and on these classes we then add fields to store data, a base type, and methods to add functionality. For real-life objects, relations exist between different types of structures, such as a I'm going to create, let's say, a default implementation, which may work for pretty much all the employee types. Let's do that first. I've introduced, very similarly to what we already have, the giveBonus method, which gives that employee a bonus. Now this, just like the other methods, make this giveBonus functionality available for all derived types. And this giveBonus is now available everywhere. I can, for example, to Mary, give her a bonus. But like I said, giveBonus might not be the same for all derived types. So I may want to let the derived types, such as manager, give their own implementation. And I haven't done that yet. So far, all the functionalities were the same in the derived types. If I want to do so, I need to make this method virtual. Virtual basically says this is the default implementation giveBonus. If a type, a derived type that is, does not give a different implementation, this giveBonus is used. Otherwise, if a more specific one is available, that one will be used. So in itself, virtual does not make the giveBonus unavailable to derived types. It still works the same at this point. But let's now go to the manager. And let us on the manager override the giveBonus functionality. I'm going to create a different implementation of the giveBonus method on the manager type. How are we going to do that? Well, I can write here public and then override void giveBonus. And here I can write my own implementation for giveBonus. There we go. We now have an implementation for the giveBonus method specific for managers. And depending on the type of the object we are going to call the giveBonus method on, a different one will be used. If the type of our object is a manager, this giveBonus will be used. Otherwise, the default, defined on employee that is going to be used. This is polymorphism. Polymorphism allows us to give different forms to the same method. And based on the type of the object we call this on, the default or the more specific one will be used. Let's see this in action. Let's go back to our program. Bethany was an employee, so Bethany has done a great job, so I'm going to give her a bonus. Then I'm going to also on Mary, on manager, call giveBonus. And finally, let's also give Kate, our store manager, a bonus. Now, although we'll see different output, I'm going to put a few breakpoints. I'm going to put a breakpoint in the manager implementation of give. There we go, we hit the first. Mary is a manager, hence manager type. So through implementations to create an employee array. so an array of the base type. And in there, I'm not going to put only employee objects. No, instead, I'm going to put Bethany, so that's an employee in there. But also Mary, our manager, is added to this array, as well as Bob Jr., so the junior researcher, base type employee, the base type, as you can see here. So this includes perform work, receive wage. So far, we have worked with regular classes to work with inheritance. There are other options that I want to highlight here, namely sealed and abstract classes. I'm going to show you sealed classes directly in a demo, as it's a pretty simple concept. While doing so, we are going to try inheriting from sealed classes, which will not be a big success, as you'll see. Say that for some reason we don't allow others using our class to derive from a class. For example, developers. They're always a bit special. So let's say that no one can actually derive from the developer type. I can actually make the class sealed. This prohibits anyone creating a type that derives from developer. I cannot, for example, now create a junior developer class. I can try. Let's see. I'm going to create a class, junior developer, and say that this inherits from developer. As you can see, we're getting a red squiggly, and that is because the base type, developer, is sealed, and it's impossible to inherit from a sealed class. This could be useful if you are, for example, creating a component, a UI component, which will also be a class, for example, and you do not want anyone else deriving from that and repackaging your classes. Then sealed really makes sense. You block other developers from deriving from your class, from your type, and creating their own implementation off of that. So far, we have introduced inheritance and we model our hierarchy so that we could move certain functionality to the base class, employee. That is a very common thing to do. And it may be so that the base class becomes something abstract, something that's more of a concept. Maybe an employee as a concept does not really exist, and we don't want the users of our classes actually instantiate an employee object directly. That too is very common. In that case, as you see on the diagram here, we still have the employee class. It still contains the name property, since that is shared, and it may contain more than just that. But we may want users of our classes to only instantiate managers, researchers, and the like. Employee could be too much of an abstraction to use. In that case, we can look at using abstract classes in C#. Now, what is an abstract class then? An abstract class in C# is used to indicate that we're modeling a concept, something that's abstract. An abstract class can contain implementations, so methods, but it can also contain methods without an implementation. This is what I mean with abstract. Maybe we simply can't give a default implementation because it's simply not concrete enough. Maybe get paid just can't be done in a generalized way. Well, then we can create an abstract method, so one without an implementation. So the inheriting types then will need to provide one. That's exactly the idea behind an abstract class. For that reason, simply because not everything has been implemented, they simply cannot be instantiated. The C# compiler simply won't allow you to do so. So how do we go about making a class abstract then? Well, this time we will add a keyword on the class declaration, and that is the abstract keyword. From then on, we can't instantiate the class anymore. Once it's abstract, we can provide methods without an implementation, as you can see here. There too, we must add the abstract keyword, and since it does not contain an implementation, we need to add a semicolon at the end. Remember, we can include methods, regular ones or virtual ones. That has not changed. So for everything where we think we can provide a default implementation, we can still do so in the abstract base class. Now, as said, because our employee class is marked as abstract, we can't create an employee instance any longer. The C# compiler simply won't let this go through. Remember that the abstract class is missing parts of the implementation, so it would be very annoying if you would invoke the not implemented methods. C# would not know what to do. Of course, we can inherit from the abstract base class. Here on the right you can now see the manager class again, which simply inherits from the employee as before. It also comes with an implementation for the abstract method using override, as before. Now this is required. When you inherit from an abstract base class, you must provide an implementation for all abstract members. Alternatively, your inheriting class too can become abstract, so its children can then become the real implementation. Let us return to Visual Studio and introduce an abstract class, including an abstract method. Then we'll inherit from this class. At this point, it's possible to create an employee, a store manager, a developer, as you've done so far in our program class. We created Bethany to be an employee, Mary to be a manager, and so on. But maybe it doesn't really make sense to let the employee be created, be instantiated. Maybe employee is just a concept and not something real, because everyone would be more specific than just an employee. And that we can actually model by making the employee class abstract. And then we can't create employees anymore, we can only create derived types, which may make sense in some cases. Maybe employee is too abstract to model, but we use it to group common functionality on the base type. But then we cannot instantiate it anymore, we can only instantiate derived types. Let me show you. Let's go back to our employee type. And let's make this class abstract now. Abstract is saying to C#, you cannot create a new instance of this anymore. In other words, it's too abstract. It is just a class that is there to model a concept, but not something that we could really instantiate. Everyone within Bethany Spy Shop is more specific than an employee. If you look at the program class again, Visual Studio will give me an error saying you cannot create an instance of the abstract type employee. Because I made this abstract, I cannot create a new instance of that anymore. I can only work with, in this case, the derived types, which are not abstract. Our abstract base class hasn't really changed. It still contains default implementations for perform work, stop working, receive wage, and so on. But it could be that it's impossible to give a default implementation, for example for receive wage, because the wage calculation might be different for every employee type. So I may not be able to just give a default implementation, and that I can model in an abstract class too by making the method itself abstract. I can say it's impossible to create this default implementation, so I'm going to make this method abstract. And now Visual Studio again starts complaining, saying it cannot declare a body because it's abstract. Indeed, I have to remove the default implementation. That's exactly what I said, I cannot give one. And I put a semicolon at the end, and Visual Studio is happy again. At this point, we've specified in the base type that a wage should be received by any employee type, but we cannot give a default implementation. But by putting abstract here, all deriving types, such as manager, will now give me an error saying that we still need to implement the receive wage method. Indeed, when we make a method abstract on the base class, all deriving types need to give their own implementation. If a class that derives from an abstract class doesn't provide an implementation for all of the abstract methods defined on the base class, it'll need to become abstract too, otherwise your code will not compile. It thus also can't be instantiated either. That is, by the way, a common thing to have. In other words, it's possible to have several levels of abstract classes. Only when all abstract members have an implementation can the class be, again, a regular non-abstract class. We can actually, in Visual Studio, click on the light bulb here and say implement the abstract class. It will then generate a bit of code that implements the receive wage method. Notice it does this by also using the override keyword, saying that from now on, when a manager is being used, this receive wage method is going to be used, which is kind of logical. We don't even have a default anymore. I can now implement this method here, and this is the specific implementation for receive wage for the manager type. All other types, such as developer, will also now start complaining because they also are missing this implementation for receive wage. Let me add that quickly here. I've now on the developer, added the receive wage, as well as on the researcher and on the store manager classes. All types that derive from an abstract class need to provide an implementation for the receive wage method. Finally, let's return to the program class. We still had an error here because we were trying to instantiate Bethany as an employee, and that is no longer possible. We should perhaps promote Bethany. Let's also make her a manager. If you look again at our array that we had in the previous demo, that is still an array of employee instances, and we are indeed calling the receive wage method on that. Again, through polymorphic behavior, when we invoke the receive wage method, it will now invoke the one on the derived types. There is none left on the base type anyway. So let's run the application and see that everything works fine again. We see that all of our employees have received indeed their wage. The method on the type itself is now being invoked. So you're going to use abstract classes when you want to model a concept that you cannot really instantiate, but you are using it to group already common functionality. And all methods that you cannot provide a default implementation for, mark them as abstract, like we have done here on the employee with our receive wage method. And all the derived types will need to provide an implementation. You can see an abstract class as a contract between the base type and the derived types. By deriving from the base class, we'll need to provide an implementation, and that really is the contract. By making a method abstract, you know that all the derived types will give an implementation for receive wage. In the final part of this module, we will look at how System Object is the base class for everything in C# and .NET. Hey Jill, I've seen this slide before, you may be thinking. Correct, we have seen it I think twice already even, but it's been slightly modified now. On the left you can see that I now have a group of classes that I've titled built-in types. There is a vast group of types that comes with .NET's base class library, including everything coming from string to exception to array and many other ones. On the right we have our own class hierarchy, so with employee and its derived types such as manager, researcher and the other ones we used. Now notice that all types actually derive from another root base class, system.object. Indeed, every built-in type, as well as every type we create, inherits from that root type. But we haven't written everywhere :object now, did we? I'm glad you noticed. Indeed, that's the default base type and it's not required to put that in. You could add it, but it's not required, and most of the time you will not do this. And if we look up the system object class, we can see that it is in fact just another class with a constructor and other members. The members on the system object are available on any type, since indeed they all inherit from this type in the end. This means that on any instance we have created, you can call, for example, the toString method, which will give a string representation of the type. The getType method will return you, on the object you call this on, the type itself. This can be useful in code where you dynamically are working with objects of different types, and based on the type you want to trigger a different implementation. Now, since system object is actually the base type of everything, this means also that literally every object we can create can be referenced through an object reference. Let's return once more to Visual Studio and understand that in fact everything inherits from system object. Now, all types that we create that do not have a specific base class defined inherit from system object. Let me prove that to you. Here's our employee class again, and we can right click on that and say go to base. Now Visual Studio will see that we don't have any custom type as the base class, so that means it inherits from the system object base class. That defines a number of members such as a constructor and a couple of methods, as you can see here. The most commonly used one here is the toString. The toString method you may have already seen when working with C# a bit, and it actually creates a toString implementation. It is a virtual method on the object base class, so anything we can create we can invoke the toString on. Let's try that. Here's our employees again. Let's say that for each employee I also want to write to the console the toString implementation. That toString implementation we get for free. It is defined on the base class, the system object class, and anything that inherits from the system object gets access to this method. So I can just invoke toString and that will give me a string representation. Let's take a look at it. The toString implementation of a type, such as store manager, is what you see here. By default, C# will show you the name of the type. That's why you see here store manager for Kevin and for Kate, and why you see junior researcher for Bob, manager for Mary, and manager also for Bethany. Now, since every type inherits from system object, everything is an object. That means that I can write the following. I can use a reference of type object, and let's call it O1, and I can point that to a new manager. Indeed, everything is an object, including our managers, as I can use an object reference to point to a manager. Now, since O1 is a reference of type object, I can only use the members defined on the base object type. I cannot, for example, on O1 call the giveBonus method, because that's defined on manager and not on object. Only the members available on object can be important concept, and it's used all the time when creating C# applications. Through inheritance,